We're going to continue our discussion of lipids. In our first example, the lipid is attached to a carbohydrate. So what we have here is a carbohydrate, D5-deoxyxylyl, careful how you spell that. Xylylofuranocide is alpha 1 to 3 with star. And what is star? Well, star is this here. The C3 alcohol, that's C3 from the steroid outlined below, makes an acetal with D5-deoxyxylylofuranocide. That's this thing here. Okay, good to know. So as soon as you see this question on your test, you're gonna start by drawing the steroid rings. You have to. We have to learn the steroid rings. They're not that hard. This is a handout from Moodle. I brought it over here. It's its own separate entity at Moodle. There are other handouts at Moodle's with other numberings of steroids that are no longer valid. It's very clear on this handout, this is the one that's valid. This system supersedes all information on previous practice exams. So you start by scribbling down your 4 steroid rings. One ring is a 6, right next to another 6, and then the next 6 is not a cross, but top right. And then a 5, straight across. A, B, C, D ring system of steroids. You must learn the numbering. It's not as hard as you think either. You just got to know where 1 is. It's off this bridgehead to the left. Right there, it says that's number 1. And they go around. And remember, steroids are numbered so that you can get outside of the rings too. And the outside starts here. Okay, so 5, 6, 7. You just got to buy into this system, people, even if you don't agree with it. Goes like that, and then 11 is up here, 12, and you don't go around the outside this time. You go down the middle. I hope I'm mimicking everything you see on the right. Yeah, and there's 17. Now, almost every steroid has 2 methyl groups. One of them is here on this bridgehead, and its carbon number is 18. Almost every steroid also has this methyl group. It's very rare when these methyls are missing. 19. So don't make 18 attached to 17, clearly. 18 is that methyl up there. 19 is that other methyl over there. 20 is what's attached to 17. So 20, and it says this steroid stops at number 20. Does it say where it stops? Steroid 1's at 27. So it says we have all of the carbons. Okay. So let's go. Let's do all the numbers. We got the 20. 1, 2, 3, 4, 5, 6, and 7. And I'll just put the numbers down. And I know I'm missing a methyl still. 20. And the methyl off of 20 is 21. And I hope you're recalling as we go that a lot of this is very terpene based, isn't it? I hope that name rings a bell. You see branches off a second carbon many times, and that's a standard methyl there. Okay. So far, we got just a standard steroid with all the carbons up to 27. We're told that. Our steroid ends at 27. We have all the normal methyl groups except the one 19 is an aldehyde. I'm just reading that right here. So just make 19 into an aldehyde. There you go. There's an alpha naphthyl on C11. That means naphthalene is attached to C11. And remember, naphthalene is two benzenes fused together. Fused means right beside each other. Just like these are fused together. Now, remember, naphthalene, the one away from the bridgehead is called alpha, and the one that's two away from the bridgehead is called beta. What do I mean by bridgehead? Well, the other ring is where the bridgeheads start. And alpha naphthyl is attached to the alpha position right here. If it was beta naphthyl, it would be attached at the next position over. Okay. Now there's alkenes. Very often there's alkenes in steroids between C5 and C6, but an alkene. 5, 6. And between C8 and H9. And C20 and C22. There we go. There's a delta lactone. Now we got to be careful. Lactone between oxygen on C24. So draw an oxygen off C24. And there's a carbonyl on C21. This is not going to be too hard. Put it in blue. There's an oxygen on C24. C21, you're told, is a carbonyl, and there's the lactone. You want to verify the alpha, beta, gamma, delta. Here we go. Alpha, beta, gamma, delta. Good, it worked. You don't need the Greek letters. I'm going to get rid of them. And what else? That's it. Nice. Now, if you want to be picky, there's this double bond is probably not going to be trans, but I'm not going to grade that. Okay. Ring is a little too small for that to be trans, but I'm not going to worry about that. So far you're doing pretty good. Got a lot of the points. The sugar's worth 3. I'd say this is worth 7, so it's about a 10-point question. So everything we've done is 7 so far. This oxygen on C3, we got to work on our sugar. So you've got your handouts handy, right? Can you find, and spelling is critical here, the name starts here, xylose. Xylose. It's probably, I think from my memory, it's a pentose with 3 stereocenters. Can you tell me how they go? Left on the top one or right? Right. So it goes right, left, and then right. And that's D-xylose. So we're going to make that into a furanose. That is this oxygen right here. Makes ring size 5. And you've been practicing all weekend. So you've got to this point here. In fact, let's just go straight to the point where it's attached to this right here. C1. So this is a alpha, and it's on a D sugar. If you've been practicing a long time, then you know alpha on all the D sugars is what your biology teacher told you. Okay? And it is going to be down, but that's not the definition of alpha. So I'm going to draw that downward. I'll draw my sugar in purple. And that's going to go to here. And we're talking about down right for the carbon number 2, up left for 3. Carbon 4 used to be down right, and it swiveled up. I'll put the green dot on it. Swiveled up there, and that also swiveled the CH2OH to the up position, which is why this is alpha. moving everything to the right. Got that dead spot on the screen. Okay, after all your flipping and there's no flipping, rotating, and remembering there was an H here. And now you see why it's alpha. The CH2OH is trans to the black O down here. These are trans. And now you got your full credit. Congratulations. Activity 1 is over. Hope I didn't miss anything. And